Thanks.
Second to last.
Yeah, that one there.
This one. It's gonna be fun. Well, I guess we just go like that. No, sorry. Okay. Well, better than nothing. Okay. Good. So hello everyone. Thank you so much for coming. It's a real pleasure to be here, and yeah, it's I love that that thing on Electron. It's really interesting. I guess I might start doing something, working on some desktop app in my spare time. So my name's Marco, and I'm a senior software engineer at Bluefin Payment Systems. I'm originally from Italy, and I'm married to a South African girl. And in recent years, I was living in Germany before moving to Ireland just a few months ago. So if you're wondering where's my accent coming from, I hope that explains it. I've got a bit of all around the world. Today, I would like to talk about technical debt, and it's going to be fun with slides like this. Yeah. So I would like to talk about technical debt, and more specifically, I would like to talk about why technical debt is not as abstract as you might think, and you can be intentional about avoiding it. So I would like to go into how, or rather, I would like to go into practical steps on how to avoid technical debt as much as possible. Now, before we move on, I guess a good question to be answered is what exactly is technical debt? So let's try to define it together, see what it is. I've got a couple of quotes which I'm going to read for you because I'm not sure if everyone can read fine. The first quote is from the Scrum Alliance website, and says, "Technical debt is a term coined by Warren Cunningham to describe the cumulative consequences of corners being cut throughout a software project's design and development." And then I've got the second quote, which is from the obviously very well-known Martin Fowler. He says that technical debt is a wonderful metaphor. In this metaphor, doing things the quick and dirty way sets us up with a technical debt, which is similar to a financial debt. So it seems to me that it really all comes down to the following. Number one, there is a proven, objectively good way to build software. Now, notice that I'm saying objectively, and I'm saying that for a reason, because I think that this really doesn't come down a lot to opinions. Something is objective regardless of what you and I may think of it. It's that way. And so what I think, and what the point that I'm trying to make today, is that there is a good way to build software, and that way is objective. In other words, it doesn't really matter what I think or what I feel about it. If you want to build good software, you have to build it a certain way. Now, what I don't mean when I say that is that there is one absolute exact way to build software. Rather, what I mean is that or the way I picture it, is by having some sort of a line in the middle, and that line would be objective. Now, everything that falls on one side of that line is good software. Everything that falls on the other side is bad software. An example of that would be someone who does TDD, test-driven development, which is obviously the idea that you don't write a single line of code unless you have it tested. And that obviously falls on the good side. If you do TDD, clearly your code, it's not only that, but clearly you're going in a good direction. But imagine we had someone else who said, look, I don't do TDD. In other words, I don't write tests every time that I write every single line of code. But what I do is I write a bunch of code, maybe, I don't know, I just go ahead, write my code, and then once a week, once every 2 weeks, I don't know, any time that I happen to have some spare time, I'll just write a bunch of tests and cover all my code that I've been writing for the past few days. And I suppose I would imagine that's something more common that we imagine. A lot of developers do that, end up just keep moving on, writing code, and then at one point you stop and say, okay, I better write some tests and covering all the code that I've been writing. And so now, regardless of, we might obviously have a conversation about the pros and cons of both approaches, TDD versus I catch up every once in a while. But the point is that both approaches, as long as you have your code tested, they both fall on the good side. So like I said, line in the middle, good software. As long as you have tests, good software. Now, what would fall definitely on the bad side would be someone who utterly, absolutely refuses to write tests. And that could be because, you say, I don't know how to write codes, how to write tests, or I don't care. I don't think it's important. I just don't want to test my code. I'll move ahead, and whatever happens, happens. Now, that obviously isn't good. That falls on the bad side, on the bad side of the objective line that is in the middle. And I think that as an industry, we need to start agreeing on these things. If you need to start agreeing on the fact that these things really don't come down a lot to opinions, but if you do it that way, you're doing it wrong, basically. So I hope that explains what I mean by having an objective, good way to build software. Point number 2 is that when you don't follow that way, you incur in technical debt. So there is a good way of build software. You could use different approaches, like I said, but you have to fall into what are the commonly accepted best practices of building good software. When you don't follow that way, everything that falls, therefore, on the bad side is software that carries some form of technical debt. Therefore, it follows that software with technical debt is objectively bad. So technical debt is objectively bad, which obviously means that as much as you can, you should try to avoid it. Now, technical debt isn't just bad code. I've used couple of examples. I've tried to use an example from writing bad code, not writing tests, or maybe writing, I could also say, obviously writing really messy code, not clean. But technical debt is also bad architecture. And that usually comes in the form of software that is over-engineered, software where someone makes a decision at a point, maybe at a starting point, and makes a decision to use certain technologies that you don't really need at that time, and that you end up being married to as you move forward, and you don't have, as you move forward, the requirements and the needs probably change for that software, and you don't have anymore the flexibility to change and to switch and to make your software useful for the purposes of the stage where you find yourself into. So bad code and also bad architecture, bad architectural choices. Now, what I would like to do is I would like to take you on a little journey. And this would be the journey of a company, a business. And I would like to go through what I call the 3 stages of growth. So we'll go through these stages in which I believe every company finds itself into, and we'll see what choices can be made, what practical, actionable choices can be made at every stage where you can go back home and go back to your work and sort of ask yourself, where does the company that I work for falls into, in which stage does it find itself? And you can, and there are practical steps, practical choices that you can make in order to avoid falling into technical debt. Now, the first stage is what I call the down to the basics stage. Now, this is the stage of a company that looks pretty much like this. You have maybe 2, 3, 5, maximum 10 people, really, really small, just starting out. There's not much going on. It's a type of company that, there's not even much bureaucracy going on. You need a day off, you ask your boss, who's got a desk just in front of you, he'll tell you yes, no need for many papers and a lot of bureaucracy, like I said. This is a stage where, as far as the software is concerned, you want to keep things really, really basic. So you want to keep things very simple as the company looks like. So like I said, the company is very simple. There's a very flat organization. There's like 2 or 3 people. So why overcomplicate things? Why over-engineering? Why make choices as far as the software is concerned that you don't even need, and you don't even know if you're going to need them as you grow? There's no need at this point to think a lot in terms of how are we going to scale when we get to that point. There's no need to think about that. What you need to do, rather, is to focus on keeping it very simple, keeping it clean, keeping your code, your software very clean. You want to rely on a rock-solid, time-tested set of tools. In other words, you don't want to go looking for the next shiny thing. You want to go and look for something that has vast, large support, where there's a large community, where there's a lot of help to be found in case you need it. Because again, the company is small. It's not as if you have 15, 20 software engineers and software architects that can find a solution to a problem when it comes up. You'd really maybe just you and 2 other guys. So you don't want to end up wasting a lot of time fixing problems just because you chose the wrong platform. So you want to go for a framework and a database and certain tools that have a large community, large understanding, and are very reliable and have been around for a while. And also what you want to do at this stage is you want to make sure that it is very easy as you move forward to make switch changes, to say, we started, for example, with this, using this database, but as we move forward, we might need a different one. So you want to make it really easy. You want to write your code in a way that's very clean, very loosely coupled, very separated, every component, every module very separated from each other in a way that makes it really easy to, at any point in the future, to say, okay, I'll take this out, I'll put this in, and it won't break many things. It won't really break anything. It'll just be fine. And this is obviously also a time where you want to write a lot of tests. You want to write as many tests as possible, not just unit tests, but also acceptance tests and integration tests. In other words, you want to lay the foundations for, in the future, when you add features, when you do stuff, you want to make it possible to do what you have to do, having that confidence that things won't break, as much as it is in your control, and it obviously sometimes isn't, but as much as it is in your control, you want to lay a very solid foundation that will make it possible for you to make changes without breaking anything. So to quickly summarize the first stage, keep it simple. Choose reliable over cool. Choose tools, like I say, that are reliable, that have been around for a while, rather than the next shiny, cool thing. Write clean code, in other words, loosely coupled, very easy to switch one component and change it with another, and write a lot of tests. The second stage of growth in a company is the focus on features stage. Now, this is a stage where life is supposed to be really good, because if you did well what you had to do in the first stage, this is a stage where you can very happily write new features, add new features, as customers' feedback comes in, as management decides to maybe slightly change the direction of the product, or just simply to add a new feature or to change something. It's life is very good, life is very happy. It's very easy, like I said, you add a new feature, you know that things aren't normally going to break. And there isn't much else to be said at this point, other than this is not the stage where you want to make important architectural choices. And what I mean by that is that if by this stage, and this is the stage where you might be having, a few thousand users on a daily, weekly, monthly basis, this isn't if at this stage you already have to think about, let's change framework, let's change database because we already can't handle that much traffic anymore, then obviously someone made a really bad choice at the first stage, because what type of database or framework or whatever it is that can't handle just a few, maybe thousands of users, just a decent normal amount of traffic, maybe going up and down, but very regular. So again, this might be the time where you start considering maybe adding a layer of caching or light things like that, but it's not the time to make important architectural choices. Anything that you chose to use in the first stage will keep working on the second stage. So again, focus on features, focus on adding stuff, be in that place that allows you to make changes and add features in half a day, 1 day, 2 days at most. Don't waste your time. So second stage, quickly summarizing, focus on features, make just very small improvements as far as the architecture is concerned, but don't waste too much time on that. If you did things well at the first stage, your platform is going to work and is reliable enough and has enough test coverage for you to keep moving forward and focusing on features. Now, the third stage of growth for a company is what I call the stage of multiplication. This is a stage where we could imagine a company, maybe an Irish company, who's been doing really well in its home market in Ireland. And this company says, okay, we've been doing really well. It's the time to launch abroad. And so we want to launch our services in the US, UK, France, Germany. So we're going to need localization and all sorts of things. But also what's going to happen is that as we launch in each new country, in a matter of a few hours, we'll have hundreds of thousands of new users subscribing to our service. And we're no longer talking just about, like I said, our home market where we've already reached a certain level of, this is where we are, this is the number of users that we have. Now we're talking about sudden growth in terms of hundreds of thousands of users that could be added on a daily basis. So that's why I call the stage of multiplication. This is a stage where numbers start going starts going crazy. Now this is a good time, and this is, in my opinion, the only time where you can start thinking about important architectural choices. This is a time where you probably should start wondering whether your framework is still good enough to handle the amount of traffic and the amount of pressure that the application is going to have to handle. This is a time where you can say, okay, but is our database going to perform well with this amount of pressure? And this is a time where, if necessary, you should change things. You should make changes. You should adopt a new database if you believe that the one you've been using so far isn't as performant as it should be. This is a time where you could perhaps start thinking about going into a microservices architecture. And obviously, there's nothing wrong with saying, as far as microservices are concerned, there's nothing wrong with saying we started with microservices at the first stage. But personally, I wouldn't recommend it. I wouldn't see the need when the thing is really, really small to start with microservices. Then that may be down to different opinions, I suppose. But if you didn't start with microservices, at the third stage, this is a good time to start thinking about it. If you believe that could be the right way to go and a good way to handle the pressure and the traffic that you have to handle at this time. The most important thing at this stage is that if things were done properly at the first and at the second stage, the key people in your team, in your development team, should have a clear path in their mind of what needs to be done in order to get from A to B. In other words, if you decide that the database you've used so far, let's say MongoDB, if you decide MongoDB isn't good enough for the type of traffic that we have to handle now, we're going to switch to Postgres. The key people in your team should have a clear path in their mind, should know exactly what needs to be done in order for Mongo to be taken out and for Postgres to become part of the architecture. And there shouldn't be much guessing and wandering around. You should, like I said, you should know what needs to be done. And the only way that this can be a reliable process where you know exactly what needs to be done is, like I said, if you did things well at the first stage. If you wrote your code in a very clean and neat and separated, every component separated from each other type of way. Otherwise, if you have, say, MongoDB code all around the place, it's going to be an absolute mission to remove MongoDB from your application and use a different database. So this is really a stage where you're going to sort of get, it's going to be very rewarding if you did things well in the prior two stages. It's going to be extremely frustrating if things went done properly at the previous two stages. So summarizing the third stage, this is the stage for important architectural decisions, and this is the stage when you should probably sit down and evaluate the need for change, evaluate every component, every part of your software and say, is this going to work? Is this going to take us where we want to get? Or do we need to change something? I have a story. I worked for a company not too long a time ago. I obviously won't mention names. I joined this company where the company was at its second stage. So doing well, doing relatively well, growing, still in its home market, in its home country, doing well, growing at a reasonable pace, not crazily, but like I said, doing well. The problem with the software, with the platform that I had to put my hands on in this company was that someone at the first stage thought it would be really, really clever to over-engineer things. In other words, we had like 3 or 4 different databases from MySQL to Postgres to Elasticsearch, everyone handling different parts of the system, and we had this really over-bloated framework with a lot of components installed that weren't absolutely necessary, and the thing was painfully slow, and it was just such a pain to do anything. Like I say, the company from a business point of view was doing reasonably well, and so what was happening was that management would come at us, development team, saying, guys, we need this new feature, and we need it in a relatively short amount of time. Customers are complaining or are giving us a certain feedback, and we need to add this new feature in maybe, I don't know, less than a week, and it was impossible. It was absolutely impossible to work on this platform. We were like 3-4 developers, so it was just an absolute pain. Bad code, virtually zero testing, test coverage, so anything you touch, you'd break something, inevitably, all the time. Now, what we had to do at that time, and this is a story that always gives me hope when I happen to work on bad platforms, remembering what we had to do when I was at that company, is that we just had to speak to management and say, look, you guys, we understand there's a need for features and working on, obviously we can't leave the platform like it is for like 6 months, no change at all, but we do need to really slow down a lot on any change, any new feature, any new thing to be added, because there's a huge amount of work that needs to be done here in terms of test coverage. We need to increase that and work night and day in order to get to a reasonable amount of a reasonable percentage of test coverage. We need to rewrite a lot of the code because it's very messy, and we need to take out a lot of unnecessary stuff. We don't need a lot of the things that are in place at the moment, and we don't even have enough systems and DevOps and operations people that can handle all of this. And it's just unmanageable. And obviously management wasn't particularly happy about that, and we got to a compromise where we wouldn't completely stop adding new features, but they would make an effort to try to slow down for a little while, and it was only a matter of a few months, 2 or 3 months. And in the meanwhile, we would work night and day trying to do what we had to do to bring the platform to a reasonable level and remove as much technical debt as we could. Now, this is a success story because in the end, after 6 months, the platform looked very, very well. It was very stable, very reliable. It was kind of a pleasure to add new features and to work on it. It was very hard to break anything because, like I said, things were well tested and well covered. And so, like I said, it's a success story. It's an encouraging story for me, at least. When I think about it, I know that there's hope, no matter how bad the code on the platform that I'm working at the moment on, that I might be working in a certain moment on. I know that there's always hope for the future. If we could do that, anything can be done. Obviously, I would guess it would be a lot harder if you were at the third stage, a multiplication, handling, hundreds of thousands of users on a daily basis, to make important changes, to sort of stop development or press the pause button like that on new features and say for the next 3 to 6 months we're not going to add anything new just because we need to fix all the problems that we have. I would guess that would be a lot harder to do. Second stage, we were still on time. Best place to do that would have been in the first stage when the thing was really small and there wasn't much pressure. That was the time where the foundations should have been laid down. So technical debt will lead only to bad things. Now, the thing is obviously that as technical debt increases, any company is less likely to succeed. And my point here today is really that the only way to really fight technical debt is, like I said at the beginning, to realize that it exists, that it's real, and that there is an objectively good way to build software and there is an objectively bad way to build software. If you can understand that, you're on a good path on avoiding technical debt. Technical debt looks differently in every stage of the company and of the software. And I hope by taking you on this little journey that I've given you, maybe a bit of a tool that you can use to see where you are and see what you can do, what practical steps you can take at this specific point in time for your company to avoid technical debt as much as possible. The thing is that doing things right, doing things the good way, will make customers happy because they'll get to use your app and experience a much stabler, a much faster probably application and experience, and so they will be happier. There's no question about it. But it will also make you as a software engineer happier because there's obviously no pleasure in working late at night, fixing bugs that shouldn't have been there in the first place. There is instead a huge pleasure, like I mentioned in the example, in working on a platform that is stable, that works, things won't normally break, and it's just pleasant. It's just much happier. It's just life is just much better, and it's just really good to be able at 6:30 in the afternoon to say, I can go home. This thing will work. Works now. Will work tomorrow. And obviously we don't have 100% control. There's human error in everything, but as much as we can, we should make an effort in that direction. Thank you very much indeed. And if you have any questions.
minutes for questions. Anybody has any?
Very interesting talk, thank you.
Thanks.
So I completely agree with you, technical debt is something that we should strive to avoid, but I'm not sure this is always something that's possible to avoid. So when technical debt, for example, collides with financial debt, and you really have to get this project demo done by this day or they're going to pull the plug, how would you balance the...
See, this is a great question, and it's probably the most common one as well. I would say one thing that... Sure, bye. I would say one thing that if you're under pressure, time-wise, finance-wise, then rather sacrifice on the new shiny cool thing, new technology that you're gonna waste 2, 3, 4 days in order to just make it work. But don't compromise on writing that one more test that will make the thing even more tested, even more reliable. Don't compromise on spending 10 more minutes just to stop and look at the code and see, okay, is this clean enough? Could I make it cleaner? Could I make it possible that when I'm gonna go do a change in the future, it's easier and I can take something out and put something in without breaking a lot of things. So I understand that, and obviously that's real life. That's what happens all the time. This is not just theory, but in general, and as much as possible, let's keep the important thing the important thing. Let's focus on making the code very reliable, as reliable as possible. And like I said, as far as the first stage goes, rather keep things really, really simple. Rather don't go down the road of the new shiny thing. Go down the road of something just old, plain old, very reliable, works well, has worked for the past 20 years. But then focus on whatever you do, make it as reliable, as tested, as clean as possible. So that's as much of an answer as I can give you. Again, I understand that in real life sometimes it may be a little idealistic, but I do think that as professionals we do have a responsibility to make the right choices. If we don't make the case for good code and test coverage and all the rest of it, who's going to make it for us? Definitely not the business people, definitely not the management, definitely not. They're not paid for that. That's not where their skills are. That's not their. They don't know it. They just don't know it. For all they know, as far as they can see a nice UI and it works, for them it's good. They don't know it. We know it, and we should make that choice as much as possible. Hope that answers.
Question: where does legacy code fall into the discussion around technical debt? Let's say you're working at a company that has 15 million lines of not necessarily the greatest code in the world, that's accumulating more and more day on day because they're in the feature mode, and they didn't make the right decisions when they needed to make them a decade ago or before anyone even knew what TDD really was. Where do you find, what would be your suggestions in that particular situation? Because you can't exactly turn around to a business person and go, oh well, we should just rewrite this 15 million line of code, because that's a non-starter really. So.
Right. Like I was saying before, one thing that I found really encouraging is when I think back about my experience at that company, where the software and the platform looked really, really bad, and the legacy code was absolutely horrendous. And in that case, we reached a bit of an agreement with management, asking them to please slow down a little bit on new features and freeing up a little bit of time for us to rewrite at least the main parts of the software initially. And then once we did, then we rewrote also all the rest of the software, but we started from the most important parts of the software, the ones where we happen to work, spend the most time working on. So I guess, one thing is that, and I understand not all companies will agree on that, will agree on let's slow down, or let's completely stop any new feature, any new thing, just because you have to rewrite your flipping code. But if possible, at least one thing is at least try to make that case. Try to go to the company, to the management, and try to make the case of, code is important, software is important. You guys, if this thing crashes, you probably lose a lot of money as a company. So if you let me fix what is currently wrong, I can assure you that in the future you'll be a lot happier. So I suppose that is something that you can do. Like I said, I together with other people did it in that company where I was working. When that's not possible, sometimes there's other solutions. Like you can say, for example, and this is just on top of my mind. There's obviously a lot of other things that one could sit down and think about, but just on top of my mind, I've heard a lot of stories of company that instead of sort of wasting their time rewriting existing stuff, they started slowly. What they did was, what they're doing is they are leaving the old as it is, but every new thing they added as a microservice. So you have this big monolith and a bunch of microservices around. I think I might be wrong, I might be completely wrong, but if I remember correctly, SoundCloud in Berlin, they did something like that. They started with a big Ruby on Rails monolith, and I'm not sure how messy it was. I'm not sure if the example is entirely relevant, but what they did at one point, they decided to switch to a microservices architecture, and what they did was they left the old as it was. They didn't change anything there rather than basic, maintenance. But every new feature, they added it as a microservice. So completely isolated, completely separated. So you know that at least the new thing is going to work. There's no, if you do that, at least that one, if you do it well, that is going to work. The old might break every once in a while, but the new is going to work. And so I suppose that's also another option that one can go for. And like I said, just on top of my mind. Yeah, hope that answers.
Thanks very much, Marco. Actually, just one question. I'm going to hijack you there a second. Did the company that you did that work for, the one that you're using as an example, did the business people appreciate it? Like 6 months later,
yes,
did they realize?
a lot. And that's why, like I said, I find it really encouraging. And I think about that story every time, actually I've thought about that story every time in the past in other companies. I've found myself a little discouraged about the current situation. Because after 6 months, these guys, the management, they were absolutely excited, because they themselves, because obviously people aren't, we think like we're the technical people and we can see all those things, and people outside, they don't see it. But the truth is, as non-technical as you can be, if you go on a website, for example, and it's painfully slow, you are going to notice it. It's not just me being all technical and talking about writing tests and all these things that people outside don't understand. There are practical consequences. And management noticed how, as we move forward, month 1, month 2, month 3, the platform kept getting faster and faster and faster and faster, and complaints from customers kept going down and down and down and down, to the point where after 3 to 4 months, we were having virtually no crash. Like, it was unheard of that the service would crash, or that we had to restart any service or anything. The thing was just working and working well, being fast and everything. So, the people will appreciate that. I guess our job is to make them understand that it will at one point look like that if they let us do what we need to do.
Great. Okay. Thanks very much, Marco.
Thanks.
Thanks.